Next up is Vadims. I'm hopefully pronouncing your last name correctly because I only know you by your first name.
Yeah.
Gezas? Gezas, thank you. From CENOS, I think we also started talking like some 3-4 years ago. They were using NetGen, and we kind of had very good talks, and especially in the beginning, since when we started off from university, they had a very similar mission to us: bring the stuff that you all do into industry.
Yeah.
And yeah, we have been in good contact since then, and I'm happy that you're here. So.
Yeah. Thank you for the introduction. So my name is Vadims. I'll start shortly with how we just came there. So during my PhD studies, I'm a physicist, not a mathematician. So I used a lot of open source for simulating industrial problems. I had the luck to be in an institute who had a connection with the industry. And yeah, there were some other colleagues of mine. One of them is now our CEO, who had the same experience. And we had a feeling that open source software is very powerful, but it kind of lacks some features to be kind of sold to the industry. I mean, not everyone in the industry wants to do that, like you told the HDiv something spaces. So yeah, they want something simple. And we thought, okay, that might be an opportunity. And yeah, besides mathematicians, there are these other researchers who do this thing. They try to understand something about market and stuff. So there is a research published in paper like probably 12 years ago, which shows what is the problem for small and medium-sized companies to kind of use simulation. And it's not about open sources in general. And so what they mention the most is the cost and the complexity. So yeah, we saw this as an opportunity because, I mean, it's not hard to be cheaper than ANSYS. And yeah, and at the same time, if we focus on doing something that our software is very focused, very easy to use for engineers, we might get our share of the market. Yes, that's how 7 years ago we founded CENOS. So 3 PhDs without any experience in selling stuff. We just started. And yeah, from now on, I'm gonna show only some nice pictures because, like Simon said, the engineers want to see nice pictures. That's what we provide. I wanted to make live demo, but yeah, I had the gut feeling it won't work as like always when you make live demo. So I just took a video which our sales team made for me. So very shortly. So what's the idea in our software? User can. This will be a radio frequency demo. So user can select a template, which is like patch antenna, dielectric antenna. So everything is predefined. He just selects the dimensions and simulates. He can do load the CAD, or he can do geometry editor. In this case, we're gonna load CAD for printed Yagi antenna on CubeSat. So these small cubic satellites, which are shipped to space in great amounts. Yeah, and then okay, he can add air, and our approach is kind of slightly different from generic software approach. We ask him to, okay, what type of application do you have? In this time, we selected custom, but and then he kind of says the user has to select what is my substrate, where is my patch and stuff like that. So, and when he has defined it, let me just quickly scroll through. Yeah, then we go to physics. We define what's the frequency, what's the material parameters, probably also from our material library. And yeah, this all perfect conductor, like mostly used. Oh no, this was the aluminum. Yeah, and then we define a port, which is coaxial port with a 50 ohm impedance, and yeah, and then we press run. Yeah, when we press run, it asks you to save the case, and yeah, then it simulates. Okay, it doesn't happen so fast usually, the simulation, I mean. So then you get results, and so this is all inside our software. Here, for example, we see S-power meter, which is very important for our RF engineers. It kind of shows the reflection coefficient. In other words, how much of the energy is reflected from what is sent from source to the antenna, how much is kind of reflected back to the source. And if you have a very low this reflection coefficient, so it's like in decibels, then it's good. Then you are you're radiating probably. Let me check. There is some more. Yeah, for example, here this will be like radiated power. We can say it's kind of inverse of reflection coefficient, because at the same frequencies we have peaks. Like most radiated power, it's 1.5 and 2.5 or something. So yeah, and besides that, yeah, we can also view like some polar plots. At that time when this video was made, it's probably half a year ago, we didn't have 3D plots in our software. Now we have all inside, but we're still allowed to use PowerView for like more advanced post-processing. Yeah, here you see that this directivity, which is kind of far field, which shows us in which directions this antenna is radiating well. Yeah, that was my short demo of what have we made. And we have, so this was an example of radio frequency. We have now we have 4 apps. So first one is radio frequency. We have customers who use it for different applications like drones or RFID, which we all use every day, even satellites. Here some nice pictures for you to have an inspiration of what is interesting for industry. You know, this is interesting to calculate how the drone, how the far field of the drone antenna, how it looks like. Probably it makes sometimes sense to calculate an antenna without the drone, but drone can also have some dielectric materials or metal parts, so it can affect the far field. And this is the RFID transmitter, I guess. Yeah. Other applications. So on the right-hand side, you see again it's a CubeSat again, so a slightly different one. And here this is a patch array. So arrays are actually also quite interesting thing, because you have multiple antennas, and if you have like bunch of them, like here for example it's 4x4, so it's 16, you get your far field, but you now want that your far field is kind of maximum, not in this direction, but maybe in that direction. And you can steer it by changing a phase shift in your patches. So you have many small antennas. If you change the phase shift, you suddenly can get your maximum in that direction or that direction. That way you can kind of enhance your communication between antennas. Okay, besides antennas, we have a big product for us is induction heating. I have a lot of customers here. And I think biggest segment in induction heating is hardening. So kind of automotive industry, and they want to do hardening. Yeah, for example, what you see here on the top is that gray area. It's a hardened part, and hardening happens in the following. So you first heat up your workpiece to, I don't know, like almost 1,000 degrees. It depends on material, but you have to be above austenization temperature, and then and then you quickly cool it down. So you quench it with a kind of like shower, and yeah, you have suddenly harder material. We have many different applications where this is used. For example, this is how it's called, gear root hardening. So this inductor hardens the root of this gear. There are different ones which can allow you to harden the tip of the gear, but yeah, very different approaches. And one particular thing that I think many of our customers like the most, that we have this we allow the scanning and rotation, which is very easy to set up in our software. I'll show that in the next slide. But basically, it's all about the design of the coil, because you want to design a coil which is kind of provides efficient heating. It is fast. It's efficient electrically, and also coil has long lifetime, because in hardening is a very fast process. You heat it up in maybe 2-3 seconds, and then you quench it in another 1 or 2. So your coil is also heating up, cooling down, and you do it for 10,000 cycles probably, or something. And every coil has a lifetime. It can be 5,000 cycles, or 10,000, or maybe 20,000. So if you optimize your coil that it doesn't have hot spots, or probably even some mechanical stresses, then you can design a better coil. Yeah, so about the scanning, the idea of scanning is that you have an inductor which provides a very localized heat, and then you just scan your piece. And this is very easy to set up in CENOS. We automatically move it. This example is turbine blade heating. Okay, this is more or less the same what we've seen before. Here it's just rotating, but again, as I said, there's a motion. It's rotating in this inside this inductor. These green ones are flux concentrators, and then you get uniformly heated workpiece, which is then quenched. And the third app, where I don't have a very sophisticated examples yet, I couldn't show them, unfortunately. But I think here we have two very nice features which people like. Is first of all, we again have this motion. This motion is important because like now in Sweden, they are trying to build this road where you drive your EV car and you charge. So this kind of system simulation is important, and also it's very often coupled with your circuit, and for this we needed to couple it with LT-Spice or external software, which allow you to calculate this part externally and then couple it with your FEM model. Okay, there's a fourth app live now. It's liquid metals pumping and steering, but I'm not showing it due to probably just a lack of time. So what CENOS actually is? So the name of CENOS is Connecting Engineering Open Source. So our idea was that we built a commercial software by using everything we can get from the open source world. And what you see on this side, these are technologies we use for our what we call a platform. And then there is a second part, that the solvers we used to develop them on our own, but now we came to the point that we probably don't want to develop them anymore. We want to have a partnership, like a mutually interesting partnership, let's say this way, like we have with SERPSIM, for example, that we have built a solver API that allows us to define, okay, we need this kind of solver, and then seek for partners who are willing to participate in this nice exercise. So far we are using NGSolve, but it's not the only one we are using within our software. It depends on the app, on the application. So we have different options there. And I would say I'd love to kind of challenge you as a community, or each one of you as an individual who is interested in such a partnership. We have a long list of things we want to implement. This is like what we want in the nearest future, and we are looking for partners who are capable and who is willing to have a partnership with us in terms of solver development. And but I also have seen very nice theoretical mathematical work here, and I want to challenge those guys to bring these things forward, that they are not they don't get lost in in scientific papers, but they probably find an application. You've noticed that, but from the applications I showed you, there was none of them was unit square. So yeah, probably it makes sense for you to ask the industry what's interesting for them, and try your solvers on examples that fits them, that fits their needs, and maybe in that way you can in the end have an answer. Is your like work or your solver really good in some niche? And I believe that for every work you can find a niche where it may outperform the others. So that's kind of invite or challenge for you guys to think about it. Yeah, that's it. Thank you for your attention.
Thank you, Vadims. Yeah, I mean, we will also give the challenge back. Give us the geometries now.
Sure.
But for sure, like, ask him, and
I think
for a lot of cases.
I think this is something that requires kind of the sense of community. That community is not only academics, but there are also these industry guys who knows what's required, and you just approach them and say, hey, I have this cool idea. Maybe application where this can be used. Maybe we can find out how to test it, how to validate it, how to benchmark it. I think we have to come closer as a community in terms of this partnership.
Is the question?
Yeah.
So in terms of application testing, the app in the end you sell to the customer.
Yeah.
In your experience, what do the customers really want? Do they want as less information as possible, just some drop-down menus and then click and push go and they get it? Or do they want
You see.
more options, or what is actually required?
Yeah, you see, that's actually, I think, why we are able to sell something, because we are definitely not there in terms of like what ANSYS has. They have more features for sure, but we still can sell to people just because we are much simpler and we offer them just these very simple drop downs. For sure, I know even some people who, when we approach them, they said, "Oh, you're too simple. You don't have this. You don't have this. I cannot modify my own equations." Okay, yeah, you're not our customer. So our customers are those like kind of smaller companies who cannot have a big R&D, and probably they have guys who are 2 days a week running simulations, and 3 days a week they're in the lab doing testing. So these are maybe different markets.
Yeah.
So I think why many people at academia are using unit square is where to get the models from.
Sure.
Okay. If there are some open models of complicated machines which are open, people can download the mesh, then the methods will also work for these complicated models. But no one of academia has the time to spend 3 months in modeling such complexities.
Sure. No, I totally.
People must be able to publish with this. So the method is working. I think this is one of the gaps between which have to be overcome.
Yeah, sure. I totally agree with you. I mean, when I was working at the university, I was also starting with the unit spheres or whatever it is. Yeah. So it's totally fine. It's just you have. I think it's important for you to not forget this is the first step, and we want all together to make the second step.
Thank you very much. And Vadims will be here later today in the evening and also tomorrow, so feel free to approach him and ask him for models.
Sure.